let's start with introducing ourselves, Lieve. So my name is Pascal Knabe. I'm CTO of Data Minded, and I'm also the product owner of our product Conveyor. If you'd ask people around what I stand for, like most people will say, like Pascal is a lot about consistency, and then I do really believe that you get simpler things, you get simplicity by being very consistent. With me, I have Lieve, senior data engineer. Can you tell me something about yourself, Lieve?
So I'm Lieven. I'm working for Data Minded in the team that's building Conveyor. I like to do the right things right. And why do I like to do that? I often see companies doing or trying to do the wrong thing faster, which usually doesn't take you where you want to go. So it's really about, picking a right direction and following through on that.
And you also have a long experience as a data engineer, right? As a consultant.
Yes, I've indeed been involved in consulting, multiple clients, multiple industries, energy, telco.
You have built a lot of data pipelines.
I've built a lot of data pipelines, some high quality, some medium quality, let's say.
It's good to know. Hopefully you'll only talk today about the high quality ones.
Of course.
So good. A very brief introduction. So 1 minute introduction into we talked briefly about hey, I'm the product owner of Conveyor. You work now in the Conveyor team. What is Conveyor? It's a solution to fast track data initiative with containerized data pipelines. Again, the data pipelines coming back, right? And there we focus on providing rapid feedback, right? For both batch and stream processing. We have native Apache Spark integration, and it runs both on AWS and Azure. It's all powered by Kubernetes. So that's a little bit context. What are we going to actually talk about today, right? There's plenty of content that's available about creating production-ready pipelines. I'm thinking about even recently, Seattle Data Guy produced this I think great blog about why your data pipeline probably isn't production ready, and it talks about these usual things like idempotency and partitioning and all the things that were also very hot when we were still using Scala for data pipelines.
The good old days.
Yeah, the good old days. And I know you very much like Scala.
I still do.
So absolutely, we'll be talking about slightly different practices, so not the usual ones, but everything that's more around these normal practices where you read about, and other things that can also contribute to data quality and getting more reliable data pipelines. So why are we actually talking about this? With Conveyor, we're supporting quite a lot of customers, and with our product, we're about supporting around 400 data and analytics engineers. So the data engineers and analytics engineers are definitely here in the right place. We support about a bit more than 1,000 production data pipelines. We have plenty more in development and staging environments, but purely running in production, a bit more than 1,000. And last but not least, these 1,000 pipelines trigger about 1.5 million jobs per month. So if you want to run at that scale, you need quality and stability. And that's something we've been pushing at a lot of our customers. So we really believe that strong practices actually leads to better data quality. So what will we actually be talking about today? We have 5 subjects that you wanted to share. The first one is all about paved roads. The second one will be about development environments and how they should mimic production as close as possible. Third one is about treating data pipelines as software artifacts. Fourth one will be about the circuit breaker pattern. I love that one, to be honest. And the last one is when things go wrong, what will you do? Right? Lieve, actually, I think the floor is yours.
Yes, let me take over the screen and then we can get started. So indeed, the first topic, and also linked to the title of our webinar, paved roads for consistency and quality standards. So what is a paved road? So I like to imagine this a bit as in this picture that I generated together with my AI assistant. So you're in the jungle, you're stuck, there's lots of trees, lots of leaves, it's very thick, you can't get through, but there is this nice paved golden path before you that you can take through the jungle, and your life is super easy and nice. And this is really, this analogy is what I like to, or what I think you should be targeting with software development or platform development, that you can offer data professionals working on your platform, on your data platform, easy ways to do the common tasks. That it should be as nice as walking to a golden path. Your engineers shouldn't be all taking out their machetes, cutting their own paths, crisscross through the jungle. You should typically have like one good way of solving your common problems.
Can you perhaps give an example of this, of a paved road that you have created in the past at some of your customers?
Yeah. So we can say, for example, a common issue that you want to solve is I want to do some distributed batch processing.
Mm-hmm.
In that case, it makes a lot of sense to say we're going to standardize on a certain framework. For example, let's take Spark. If you have like 5 different compute engines that you're using across your organization, there are multiple ones. Then basically what happens is you're building the same technical things multiple times across your organization. So you lose a lot of efficiency. Also, when you're moving projects or moving teams, you need to learn new technology stacks.
Mm-hmm.
And in the end, they all more or less do the same thing.
Mm-hmm.
So you lose a lot of velocity there. And I think by standardizing on this set of tools and providing a sensible default, this does not have to mean that you can only do that. If you have a very good reason to deviate from it, if the golden path doesn't take you where you want to go, then of course, by all means, build your own, right?
So you can still take your machete and go through the jungle if there's no path towards where you need to go.
Yes, indeed.
Okay.
Yeah.
Okay, perhaps another question, like we mentioned paved roads on the same side, you showed like golden paths. I typically use these two concepts and I for me they're the same thing, but is there actually a difference between a paved road and a golden path?
So there is a slight difference in connotation. So the golden path would be like really an organizational standard that you I don't like to say enforce, but like strongly recommend. Like if you're doing this kind of or you're tackling this kind of problem, this is like the one recommended way you should try to solve that problem.
Okay.
And a paved road is a little bit less strict, I would say, where you say like we recommend this, but it's not like super defined yet. So a paved road can move to a golden path, let's say.
Okay. But
in practice, these are more.
Okay, so I'm not saying anything stupid when I consider these things the same thing. So there are some things on the slide like, hey, it's sensible defaults for your organization. It can accelerate you, right? You're not reinventing things. How does this actually lead to better data quality?
Well, for example, one of the ways is if you standardize on data quality tooling and what data quality means within your organization, also having a bit of a common language. It also helps teams communicate better about what to expect from each other and then align on what data quality is and then enforce those standards. On the other side, there's also like purely from a practical standpoint, the less time you spend on doing infrastructure setup and configuring 5 different processing engines, if you just do it once, do it well, then the 4 times that you didn't have to do it, that's time you can actually spend working with your data and improving the quality.
Yeah. So quickly to summarize, it's basically saying like, you want to somehow standardize, right? Consistency, absolutely my thing. Standardize in how you actually measure data quality, because otherwise, like if I say my data quality is 5 and another team says my data quality is purple, it doesn't tell me anything about data quality, right? And on the same side, you're saying like by standardizing, you actually give engineers more time to working on the pipeline instead of all the things that go around it, typically leading to better data quality.
Yeah, the more time you spend improving your data quality, then normally it should improve.
Yeah, normally it should, yes. No? Oh, cool. I think I got it. I think we can move on to the next point.
Yes. So testing in production-like environments. It's also a problem that we often see working for clients. So you get into a new project, you're asked to build a data pipeline. So of course you ask, hey, can I access this data set or the source system? And then there is like a team of data architects or a security team or I don't know, some guard keepers gatekeepers, and they tell you no, you cannot access the data. This is production data. You're a developer. Developers are only allowed to touch development data, and typically the development data does not really match production. So then, what can you offer as an alternative for production data? Anonymized data, synthetic data, or sample of the data set. If you're not allowed to see the full data set.
I've seen all three solutions implemented in various organizations.
Yeah, indeed. But unfortunately, for all three of these, there are also some downsides. So if you want to work on data quality, that is, or you want to have data that is qualitative, which usually you do. But so if you anonymize it, that means you remove information from your data set. If the data is not present, you can also not test your dataset for quality or work around issues that there are. Synthetic data, so that means you will actually be generating your own data. So you have a schema, you have a distribution for your data, and then you generate the data sets.
And with GenAI, this has become easier than ever.
Yeah, indeed. You could ask an LLM like, this is what I want, more or less, generate me some random stuff, and it will happily comply. Of course, if you then say, I want to measure the quality on it, you've just completely made it up, or you've generated from a statistical distribution. Of course, the data that you ask to be a certain distribution will match that distribution perfectly, right?
No, absolutely.
But then once you move to the real world and get real data, then it probably won't match 100%, and you will start encountering issues. And then for sample data, it's again more or less the same story. For the part that you have, you usually then there you can find the quality issues that there are, but your real data set will be a lot larger. There will be edge cases there that you haven't seen in your sample, so those things will start breaking in production then as well.
Yeah. So, and that's the case I've definitely seen the most, the sample data, where I typically write unit tests against a couple of samples I got from the customer, implemented the data pipeline, and then you go to production, and then you end up debugging in production.
Yes, indeed. So none of these are really a good solution. So what we should do then as well, basically you should, if you want to be sure that your data pipelines will work for production data, you should build them based on production data, right? But then how do you actually then convince your team of architects or security team that this is okay to do? Well, the key insight here, and the thing that most often goes wrong, is that this access to data is not an all or nothing thing. It's not because you want to access sensor data coming from your machine part, for instance, that you need to access all the sensitive HR data that there is. This is not an all or nothing thing. Just you have requirements that you need to implement for your pipeline. The data that is needed for those requirements, that's what you should have access to, and all the rest you don't care. And most of the time, depending on your industry, of course, the data that you're working with in an organization, most of it is not really that sensitive, and there's not really an issue in getting access to production data.
No, perhaps a follow-up, like we've been talking, so what we see at customers is typically like even, and I have implemented as well, especially if the data isn't sensitive, right? That you get in your development environments, you get like read access, right? But you're not allowed to write. And then of course, once you go to production, you basically get read write and such.
Indeed. Yeah. So it's indeed a common pattern that works quite well, where you're allowed to read from more important environments, but you cannot write back to avoid polluting those environments.
Yeah, no, absolutely makes sense. So we're talking here mainly about data environments, right? What about computer environments, right? I had a situation where something worked perfectly on my machines, but then I need to bring it to production, and then the production system is completely different, and I get completely different results.
Yeah, indeed. Yeah, so also there, you need to try to match your production environment as closely as possible. So what a good solution for this is to have remote developer environments that actually match your production environment as closely as possible, like the same machine architecture and stuff. On cloud environments, this is typically pretty easy to do, or relatively easy. You can spin up as large as a cluster as you want for the time you're developing. If you're done with them, you throw them away again. And then cost-wise, it's more or less okay.
Cool, makes sense. I think we can move on to the next point.
Yes. So it's about treating your data pipelines as software artifacts. You can argue about whether data engineering is software engineering, yes or no. This is not the place to have that debate, but there are lessons to be taken, and it's, I think, a good idea to treat data pipelines as software artifacts because it brings some benefits, right? What do I mean by treating it as software artifacts? Basically, the first step is use source code. Your data pipelines are code. Source code or source repositories have been around for many, many years now, so use them. They work amazingly well. So you have your source code checked into source control. From that source, you generate an artifact that is reproducible. So your source code is one-on-one linked to an artifact. For the sake of this webinar, let's consider this artifact to be a Docker container. It's quite standardized nowadays. It's easy to reason about. And this container image is then the artifact that you will be testing in your different environments. You're not supposed to, or you shouldn't do new builds for each environment that you want to deploy to, because then subtle things might change. That also means your build was not entirely reproducible, which is also not good. But then also it means you're testing different artifacts in different environments. So stuff that you have then validated that works in your QA environment, you do a rebuild, and then you might update a library that you weren't intending to, and it breaks in production. So this is not what you want.
So you don't want to reduce any changes when you move from your development environment where you have tested things to QA and production. You don't want to change anything. You want to leave everything as static as possible.
Yes, because it's the only way to guarantee that what you have tested will actually work. Yeah. So the benefits of this, well, first of all, reproducibility. And then with that, I mean, really, you are able to link your version of the source code to the version that is running in production or another environment. Now, why is it important? Suppose that something goes wrong in production, then you should be able to trace back, like, the version of the code that is running in production. Which version is that, right? Because I might have made the artifacts like 2 weeks ago, and then it went to my approval process. But that means in the meantime, we might have continued working on the code. So the code that is my code base today, the latest version of the code, will not be the code that was failing in production. And I need to be able to link that back and able to debug effectively. Also, if you know when your traces were released and something breaks, then it also allows you to do an easy rollback, or it enables easy rollbacks, let's say. It does not provide it out of the box per se, but it allows you to roll back to a previously working version if you did introduce a bug in production.
So to summarize here, I think how does this contribute to data quality is don't introduce any changes between moving things through production. I think it's still very valuable, right? We talk about like these environments, and I know sometimes people are a little bit allergic to these different environments, but it still makes sense to like go to all these environments and don't introduce any changes there, because like any change like that you introduce after testing things like might result in failure, so don't, right? And this is something commonly done in software practice, and this is something we should apply to pipelines as well.
Absolutely.
Okay, cool, got it. I think there's now like well, we can go on to the next one, but I do want to do a small interaction again.
Yes.
So I have another question set up for you, and it's all about like what tools are you currently using to test data quality? I know we internally and in our consultancy engagement we're using multiple. I don't know. Do you have a preference, Lieve?
I don't really have a strong preference. I think you should pick a library that interfaces well with the tools you've chosen to standardize on, because most of these tools, they have they have typically multiple integrations, but some of these work better than others. So in that sense, I think the key is to figure out like what works the best for my engine.
Cool. So we're getting a few results in, not that many. It's a little bit changing. There's the other again in the chat. Like I would be very interested in like what the other is. There's one person who says like they're not testing data quality at all. I'm happy to see that 2 people are using Soda. There's a lot of DBT testing being used, which I think is the greatest value that DBT brought. Well, they brought a lot of like good practices into this analytics space, and I think this is where DBT really shines. And then there's one person using Great Expectations, two people using Soda, and some other. I'll leave it open for a couple more, and like I'm getting something into like. There's a robot framework. I don't know that one, so that will be interesting to visit later on. And there's custom synergy checks with crumbs and this. That's also very interesting to know. I'll end this interaction and I'll show the results. And then I think this completely links actually to your next topic about circuit breakers.
Indeed. So circuit breakers for data pipelines. So why do I want to talk about this? Well, I've generated again an image of my ideal world where data is pristine, it flows beautifully, your pipelines never break, and your data is always consistent and on time. Of course, this is a utopia. It doesn't exist in the real world. Your pipelines might be a bit rusty. They might get a bit polluted from time to time, or blocked. Data is not flowing.
I would say garbage in, garbage out when I see that picture.
So basically, when this happens, when your data, something change upstream, can be error. Sensor errors can be anything. A source system that is down.
A table that changed
its schema. You want to avoid your users having to clean up the mess, right? So as our data engineers, we take our job seriously, and we want to provide our users with quality data. And basically, so we've talked about testing of our software artifacts, our pipelines. We want to test our data as well, and this is where the data quality tooling comes in. And this is also, you can integrate this in the circuit breaker pattern. So I've made this schema for you. So what happens is data is coming in from the left from your source system, as it always does. You do your transformations and you build your new data set, which is labeled table here. So that's your first step, but this table is not yet visible for your users. Then you have a second step, your publication step. And in this step, you will check your data contract. So the data contract is a term I use now, basically to represent your suite of data quality checks that you want to enforce on this data. If your table passes all these checks, then beautiful, you can push your data along to the anti-corruption layer. If not, then you stop the flow. Then basically what happens is your user can still read the anti-corruption layer. That's what it's there for. It's the data layer that you guarantee to always be available and in the format that you want it to be. But it might not be up to date anymore because upstream something went wrong and you don't have, the good data is simply not there.
And so in this check, this is where these data quality tooling comes in, right? This is where you typically run your DBT tests, or you run your Soda test suite, or your Great Expectations, or any of these things. You run there, you run it to like a temporary table, and then when you do your checks, and then if all your checks pass, then you only make it available to end users. If it doesn't pass your checks, they're still reading like the more stale data, like the previous version. And like you put it at the bottom, right? This is also called often the what I call the WAP pattern, or WAP pattern.
Right, what the publisher needs. It's the same thing. It has different names. So you write the data, then you audit it, and when you've confirmed that the data is good, then only then you publish it.
I've seen actually implementations like I think Snowflake Zero Copy really helps there. Also like Spark with Iceberg nowadays, where you can have like different branches being written and then upgrade them. That's really where these technologies shine.
To make the publishing step as smooth as possible and as low latency as possible.
Awesome.
Indeed. All right. So our circuit breaker, it might trip, stuff might go wrong. We can build the best pipelines in the world, but not everything is in our control, sadly. So eventually something will break.
This always remembers me of Werner Vogel's, like the AWS guy, like who says like everything fails all the time, right? So you have to deal and assume that everything in the end will fail.
Yeah. So why is this important, or how should you approach this monitoring and alerting? it is really a common problem for every engineer in your organization. So this is something we've talked about paved roads in the start of this webinar. This is something I believe that should very much be part of it. It's something that you need to solve. It needs to be solved well, and it needs to be accessible for everyone. So it's a perfect candidate. Why is it important that you solve this well? And I think this is about keeping trust within your organization, keeping trust with the consumers of your data. If you know that something went wrong with my data pipeline, the data is not being refreshed, you built a circuit breaker tripped, okay, stuff happens, but then you can proactively communicate about it, right? Like, hey users, I'm very sorry, there has been a problem, we're working to resolve it, your data is not up to date. We'll give you an update as soon as we find out what went wrong and when we can fix it.
It's way better to proactively communicate to all your data consumers, like, hey, my pipeline failed, like my data is not in the state it should be in, rather than then come to you and say like, hey, why am I looking at old data, or why
is my data completely garbage?
Yeah,
that's even worse.
Yeah.
And it's not a good look, right? Yeah, and then I think a final feature or a design decision that you should take when implementing this part of your golden road. It should be super easy for you as an engineer to have easy access to all the telemetry of your application, of your data pipeline. You should have like a single view where you can view the logs, the performance metrics of your job, when did it start, when did it trip. Basically, get all the tooling in place to make sure you can resolve the issue as soon as possible.
I do want to perhaps add on that, like, don't go overboard with alerting, because like I've been in a situation where we implemented so many alerts that something would like create a false positive, and like some alarms were always beeping, and after a while you get alert fatigue and you stop watching for alerts.
Yeah.
So don't boil the ocean there either. Be pragmatic, look at really the key things you want to monitor. Don't try to monitoring everything from day one. Be very pragmatic with that.
Yeah, indeed.
Cool. I think we can go on to the next one, right? So this is like the key takeaways. Like these were the 5 subjects we wanted to share. Like, can you summarize again?
I can summarize my 5 insights. So you should invest in paved roads. I think that's clear. There are common problems across your organization. Solve them once, solve them well, don't reinvent the wheel. You can only really measure and define and check your data quality against actual production data. If your data is not representative, then your tests that you define in the data will be unrepresentative, and your data quality will be unmeasurable and stuff will break in production. Testing is super important. You should test your data pipelines, which are defined as codes. You should also test your data. The WAP pattern can help you there, avoiding publishing data that fails your tests. You should know which code you're running in production. Use version control. It's there, it works well. And make sure your artifacts are reproducible and linked to that source code. And when things do inevitably go wrong, be in a proactive position, don't be reactive, and your monitoring system should enable this fast detection, fast alerting, and allow you to, or help you to resolve your failures fast as well.
Cool. Thanks for sharing your insights, Lisa. We have 2 questions. Let me start with the first one.